going to take a look at graphing a piecewise function first. Here, take a look at this function. I'm going to graph this first one in red. And notice this only occurs when our x values are less than 1. So I'm going to draw an imaginary green line right here. This is the line where x is 1. And we know this is only true for x values less than 1. So I know that this function 2x plus 3, this piece of our piecewise function, only exists over here to the left of when x is 1, over here to the left of that green line. So I know my y-intercept is 3, and I know my slope is 2. And of course, I could draw some points that would be on this line over here to the right of my green line, but I don't need those because those are when our x values are greater than 1. I'm going to draw my arrow in this direction, pointing towards all my x values that are less than 1. And notice right here at 1, we cannot equal, so I want to make it clear that it is an open circle right there where our x value is 1. And then moving on to the second part, this is true if x is equal to 1 or if x is equal to 2 or if it's anywhere in between. So I'm going to do another imaginary green line, this time right here at 2, and I know it's going to occur in between these two. So this time we have a y-intercept at 2. I have a slope of -1. Notice I could plot a lot of points that are on this line, but I know it's only going to be true in between my two green lines that I drew, in between the values of where x is 1 and where x is 2. And so I don't want to connect the rest of them. I don't want to worry about the rest of this. Everything outside of these green lines is not part of our piecewise function. We can equal it 1, so I'm going to make sure this is a closed circle. I can equal it 2, so I'm going to make sure this is a closed circle. And this is only existing in between those two pieces, in between those two x values. Finally, we have a constant of 3. The output's always going to be 3 for any x value greater than 2. So over here to the right, it's always going to be 3. And it cannot equal at 2. It's a constant output of 3 with a slope of 0 for any x value greater than 2. Let's talk about the domain and range real quick. The domain, well, thinking about possible x values, we got this arrow pointing to the right, this arrow is pointing to the left. We're including even the x values inside of here when we are kind of jumping between the pieces. Any x, any value we can think of is going to satisfy these 3 inequalities. So our domain is all real numbers. Any real number I can think of satisfies those inequalities. It is going to have a point on this graph. My range, a little bit more specific. I can have any y value down here, and my highest y value is about right here. Any y value less than 5 can be an output, and I cannot equal at 5 because of that open circle. So y is strictly any, our range is strictly any number less than 5.